Now the example. Now if you look at the example, they talk about, they consider an experiment where 3 coins are flipped simultaneously. So, and then now what did you do if you have something like this? You should list out all the possible outcome. Alright, this one you have done in chapter 2. So if you flip 3 coins simultaneously, your sample space should have whether you're going to get a hit, and then whether you get a hit, tail, and then whether you get a hit, tail, hit, what else? Or whether you get what else, yeah? Whether you get a hit, tail, and tail. Now again, if you cannot list it out, you have to imagine a tree diagram or draw your tree diagram. Okay, and then what else you can have? You can have a tail, hit, and then you can have a tail, hit, tail, and then tail, hit, and then you can have tail, tail. So total of the sample should be 8. Why is it 8? Because you have 3 coins. So one coin have 2 outcomes. If you multiply by 3 coins, which is 2 outcome, another 2 outcome, you will get 8 possible outcome. Okay? Now, over here, they take the random variable. You see, if x denote as the number of tail, means that this x is gonna be your random variable. Wait a second. Right. Your random variable, x should be, always write your random variable is the number of tails. Okay, always write your random variable. What is it? Determine your random variable. Do just simply want to list out, tabulate and so on. Okay, write down what is your random variable. Once you get this, then you can know what is it. Now this table, basically, if you look at this table, this one, they actually put it in a nicer way where the possible outcome, where you have this one and the number of tail. Now number of tail, if you look at the sample over here, you can have, like, for example, hit. Is there any tail? For this example, hit. Is there any tail? There are 0 tail over here. So you can put it as the number of tail is 0. And if you look at hit, tail, this one you have 1 tail. Is it only 1 tail? This particular sample only? No. If you look at over here, hit, tail, hit, also 1 tail. And then there is another one which is tail, hit. That's why they list out this one for number of tail 1. Alright? And then if you look at over here, there are 2 tails and 1 hit. Alright? And this is not the only outcome. You can have also here 2 tails, 1 hit, and 2 tails, 1 hit. So they list out, when the number of tail is 2, they list a possible outcome over here. And over here, the last part, you will have 3 tails. So there's only 1, so tail, 1. Okay, that's how you get the random variable. Now, if they ask you to list the probability distribution of x, then you can represent through the table, graph, or function. Now over here, they represent it in table. So what they do is that, now I'm going to write it again. So what they do is that, you just simply draw your table. So you have x, and you must have your probability of x. Now, what are the x? X just now is the number of tails. So, what are the possible value of number of tails? You might get 0, 1, 2, 3. Write it down. 0, 1, 2, and 3. Okay? Now, for zeros, okay. Now, how many possible outcome are there? There is particular one possible outcome. Out of total how many samples? There are 8 out of it. So you can say that it is 1 over by 8, your probability. Now for 1, how many? 1, 2, 3. So you can say that it is 3 over by 8, your probability. And for 2, still the same, 1, 2, 3. So you can have 3 over by 8. And for 3, you can have only 1, which is tail, tail, tail. So this is 1 over by 8. There you are. You got already your table over here. Now my table might not be nice, but it is still a table. Okay? So this is how you do a probability distribution of X in table form. Now, instead of doing a table form, now this is actually using table. Now number 1, table. Now for number 2, I'm going to write it over here because we don't have a space. So for number 2, let's say you want to put it in the graph. So in the graph, basically you must have X and Y. So your X-axis is your random variable X and your Y-axis is your PX. And then write it down 0, 1, 2, 3. And your PX, you're going to have 1 over 8 and 3 over 8. Of course, over here, 1 over 8 is much smaller than 3 over 8. So you just simply put 3 over 8. So at 0, what is the probability? It's going to be 1 over 8. So you just draw a line. For 1, the probability is 3 over 8. So draw a line. For 2, 3 over 8. And for 3, 1 over 8. There you have it. This is the probability, discrete probability distribution in terms of graph. Okay. Now, in a function, so where should I write? Okay, I'm going to show you. All right, by the way, in your book, you should have a line graph already. Okay, you can look at there. Okay, now I'm going to show you how to write in a function. All right, in a function, now what is the function over here is Px, basically your probability Px. Now this is actually your piecewise defined function, what you have done in Maths 1. So what you have is that for your function, what are the value that you have over here, Px? You have whether 1 over 8 or 3 over 8. So you have 1 over 8 or 3 over 8. When is it happen for X that it is your Px 1 over X? It happened when X equivalent to whether 0 or 3. So you put it whether 0 or 3. And for 3 over 8, it's going to be X equivalent to whether it's 1 or 2. Now, you have to add another one actually. I have to wrap it up a bit. Okay. Now, you have to add another one when happen that is X is elsewhere. Elsewhere means, for example, X equivalent to 4, 5, 6. So what happened is that your probability going to get 0. Okay, I hope you understand it. And there are a few questions that you can try later. I will give you your mahala work.